We're going to continue our discussion of section 1.5 on solving inequalities, and in this video we're going to focus on writing and solving compound inequalities. So let's first of all begin with a vocabulary term. Let's discuss what a compound inequality is, since that's what our video focus is going to be. A compound inequality is where you combine two inequalities by using an and or an or between them. So a very simple example of a compound inequality might be x is less than 3 and x is greater than 2. Now let's take a moment and solve this inequality. So we're going to solve one that has an and between it. So we have 2x plus 3 is less than 9 and 4x minus 2 is greater than or equal to negative 18. So let's solve the first inequality just like we would normally do. We're going to subtract a 3 from both sides. And get that 2x would be less than 6. Then we're going to divide by 2. And get that x would be less than 3. Now we'll do the same thing to the other side, to the other inequality, and we're going to take and add 2 to both sides and get that 4x would be greater than or equal to negative 16, divide by 4, and x would be greater than or equal to negative 4. And now what we want to do is graph the solution. So I'm going to actually graph each of those solutions in different colors, and then we'll see how we graph the solution to the entire problem. So let's kind of mark off here on our number line and graph. Let's start with x is less than 3. So if it's less than 3, and I'm going to do it above the number line, x is less than 3 would start here, open circle because we're not equal to, and we would shade everything below that point. So there would be the graph of x is less than 3. Now let's graph x is greater than or equal to negative 4. So we come down here to negative 4. We're going to have a closed circle, and we're going to shade everything above. Now what we're looking for is the fact that it has to be in both of those groups. So if you look at that, that would tell me that the very first thing I want to do is look at just this part, the part where we shaded twice. But if I now color in what my graph is going to look like, or my solution is going to look like, here at positive or negative 4, that point has been shaded in both of them. So I'm going to shade negative 4. Then everything here has been used in both of my inequalities. Then I'll get all the way up here to positive 3. And I see that positive 3 was included in the blue line, but excluded from my red one. So that it has to be excluded in my overall solution. So this purple line here is my final solution to that entire problem. Now let's look at an OR problem, and you actually do it very similar to what we just did with the last problem. We're going to still solve just like we would normally do, so we're going to add 7 and get x is less than 2. And then I'm going to come over here and I'm going to subtract 4. Let's switch colors. So we'll subtract 4. Get negative x is less than negative 5, divide by negative 1, so we have positive x. But remember, when we divide by a negative, we have to flip the inequality sign, so we now have x is greater than positive 5. So let's graph the two of those. All right, so our first one, we want to graph x is less than 2. So we're going to have an open circle at 2. Let's actually plot that above. Open circle at 2 and everything below it. And then we have x is greater than 5. So greater than 5 would be open circle here and everything above it. But this time the problem is an OR problem. When it's an OR problem, what you do is you just combine those two answers into one answer. You don't have to worry about whether or not they share anything. So then the final solution would be anything that's in either of these two graphs. So that means everything here is in the final solution because it's in the red line, and anything here is in the final solution because it was colored by the green line. And there's your solution to the overall inequality.